I'm Brian Swanson from Kitmasters, and I'm going to demonstrate how our Gold Top Rebuild Kit is solving some of the industry's problems with spring engaged fan clutches. The primary cause of failure in the current generation of spring engaged fan clutches is pulley bearing failure. These pulley bearings are failing at a much higher than acceptable rate. The industry has made several attempts to improve the quality of these pulley bearings. We've gone from one bearing manufacturer to another, from one bearing grease to another, from one bearing seal to another. There is still, however, a higher than acceptable level of fan clutch failures due to pulley bearings. Kitmasters believes that the bearings themselves are not the problem. We believe that torque is the problem. Every fan blade requires a certain amount of torque, and every fan clutch produces a certain amount of torque. When we talk about torque in a spring engaged fan clutch, what we're talking about is the fan clutch's ability to engage and hold on to the fan blade. What happens is the thermal switch sends a message to the solenoid valve to shut off the air supply to the fan clutch. Without that air supply holding that spring back, the spring comes down and engages the friction material to the fan blade. But it takes a certain amount of spring pressure and a certain quality of friction material to hold onto that fan blade and not slip. If you had a small spring and a weak friction material, you'd have a low amount of torque. If you have a massive spring and a high quality friction material, you'd have a higher amount of torque. So the interplay between the spring pressure and the friction material is what drives fan clutch torque. A current OE fan clutch design advertises 2,100 inch-pounds of torque. At the time this fan clutch was designed, the biggest fan blade in our industry was a 9-blade 28-inch fan. Unfortunately, diesel emission requirements happened at about the same time. As the emission requirements came into effect, the engines began to run hotter. The hotter running engines required bigger cooling packages. The bigger cooling packages meant bigger fan blades. We moved from a 9-blade 28-inch fan to a 9-blade 30, to a 9-blade 32, to an 11-blade 30, to an 11-blade 32, to an 11-blade 34, to an 11-blade 36-inch fan. An 11-blade 32-inch fan spinning at 2,000 RPMs requires about 2,400 inch-pounds of torque. An 11-blade 34-inch fan requires about 2,600 inch-pounds of torque, and an 11-blade 36-inch fan requires about 2,800 inch-pounds of torque. Now you have fan blades that require more torque than the OE fan clutch is capable of producing. That's the problem. You have fan blades that require more torque than the OE fan clutch is capable of producing. What happens when a fan clutch engages is it slips a little bit and then it holds. But as the RPMs increase, the fan blade has a thrust factor. Just like an airplane propeller, it wants to pull away from the fan clutch. So as the RPMs increase and thrust becomes a factor, and the torque required by the fan blade begins to exceed the torque generated by the fan clutch, the fan blade slips. What happens when a fan blade slips? It causes massive internal heat. What does massive internal heat cause? Bearing failure. Lack of torque is the problem.